Alright guys, so we've done the fundamental theorem of algebra and then we did rational functions. So now we're going to do rational inequalities. So when you do rational inequalities, what you want to do is you want to simplify your problem to where it's either less than or equal to 0, less than 0, greater than 0, greater than or equal to 0. And then we're going to talk about how to set the top and bottom equal to 0 and solve it from there. So this first one, kind of start with an easy one. It's already set up for you. So I have 2x plus 3 over x minus 1 is less than or equal to 0. So what you want to do is you want to set the bottom equal to 0 and the top equal to 0. You're going to solve it. So once I solve it, I'm going to make a number line. Now on your number line, whatever's on the bottom is always open circle. Bottom, always open circle. If it's on top and it's got a less than or equal to sign, then it's going to be a closed circle. So now what you have to do with rational inequalities is you have to have test points. So the easiest one is usually 0, so find out where 0 would be in your number line. In this case, it's going to be in between them. So then I'm going to plug in 0, and I'm going to solve it. So I made 3 over negative 1. So in this case, I get a negative 3 is less than or equal to 0, which is true. So I would end up shading in between. Now, just kind of like of a hint, if you shade in between, that's all you're ever going to shade. Technically, you're supposed to do other test points, but it skips around always. So like I could shade left, skip the middle, shade to the right, or I could just shade the middle. So in this case, my answer is going to be negative 3 halves, comma, 1. It's going to have a parenthesis. Negative 3 halves is going to have a bracket because it was a closed circle. So this was a negative number, which means these are going to be positive, which means they're going to be false statements. So if I plugged in 2, for example, right, I would get a positive number, which means a positive number is not less than or equal to 0. Just use common sense there. So it's not going to be true. That was kind of the easy one to start with. Now B, if you notice, I don't have it equal to 0. So what I'm going to do is I'm going to subtract this 3 to the other side. And the thing is, you can combine these because they have the same denominator. So I'm going to say x minus 3 over 2x minus 1 is greater than or equal to 0. And now it just kind of turns into what we just did. I'm going to set the bottom equal to 0. I'm going to set the top equal to 0. So when I do that, I'm going to get x equals 1/2 and x equals 3. So again, you make your number line. The bottom is always an open circle. The top's based off the inequality sign, which one's greater than or equal to, so it's going to be a closed circle. So then I'm going to pick 0. Well, 0 is on the left of 1/2 this time. I'm going to plug it in and I'm going to see if it works. So I'm going to say 0 minus 3 over 2 times 0 minus 1, which would be negative 3 over negative 1, which would be a positive number. So is a positive going to be greater than 0? Well, the answer is yes. So I want to shade to the left here, which means this is going to be a negative, so it's not going to work. And then this is going to be positive, so it's going to work. And so that's like kind of the pattern, right? If this works, the left, the next section won't, and then the next section will. And it's always going to be like that. So I'd say negative infinity to 1/2, union, 3 to infinity would be my answer. All right. So now they kind of get a little bit tougher because the denominators aren't going to be the same anymore. So this one, I have to multiply the left side by x minus 5 over x minus 5. So on top, I'm going to get 6x squared minus 30x over x minus 5 greater than 36 over x minus 5. Now they have the same denominator, so I'm going to move this to the other side. So I'm going to subtract it because it was a positive. So I'm going to have 6x squared minus 30x minus 36 over x minus 5 greater than 0. I'm going to go ahead and factor the top. So I'm going to factor out a 6. And then I'm going to say x minus 6, x plus 1 over x minus 5. Erase that, make plus 1. Because remember, it has to multiply to negative 6 to add up to that negative 5 in the middle. So then I set the top and bottom equal to 0, so I'm going to say x minus 6 equals 0, x plus 1 equals 0, x minus 5 equals 0. I'm going to solve them. Do this. Move it over. So I would add 6, so I get x equals 6, subtract 1, I get x equals negative 1, add 5, I would get x equals 5. So then I'm going to put those on a number line. Look and see in my circles, the bottom's always an open circle, and this one's just greater than, so they're all going to be open circles, which is kind of nice. So then I'm going to pick a test point. Usually the easiest one is 0. We're going to plug in 0. So if you think about this, it's 6. They kind of make it easy on yourself. Just think about what the sign would be. This right here would be a negative. This would be a positive. So on top, I'm going to have a positive times a negative times a positive, which will be a negative, over the bottom's going to be a negative. So a negative over a negative would be a positive answer. So is a positive answer going to be greater than 0? Well, the answer is yes. So I'm going to shade there because it's true, which means this is going to be negative, this is going to be negative, and then this last one is going to be positive. So my answer would be negative 1 to 5 union 6 to infinity. Okay. This one, a little bit tougher again, just because they don't have the same denominator, so I need to multiply by the opposite denominator. But before I do that, I'm going to move this to the other side. And then I'm going to multiply the left fraction by x plus 3 over x plus 3, and the right fraction by x minus 4 over x minus 4. And we've done rational equations before, we just haven't done inequalities. So the left side is going to become negative x minus 3 over x plus 3 x minus 4. The right side is going to become positive x minus 4 over x plus 3 x minus 4. So I just combined them. So now I got to combine the tops. And when you do that, notice you just get negative 7 on top. So again, I would set the top and bottom equal to 0. Well, really all I have to worry about on this one is just the bottom. I'm going to make my number line. Negative 3 and 4, they're both on bottom, so they're going to be open circles. I'm going to pick a test point of 0 again. I'm just thinking about my sign. So it's a negative on top. It's going to be a positive times a negative on the bottom, which would be a negative. So negative over negative would equal a positive number. Is a positive number going to be less than 0? No, so that's a false statement. So I want to shade on the sections that it's not going to be positive, which would be to the left and to the right. So negative infinity to negative 3, union 4 to infinity. Last one, I'm going to add this 4 over. Notice the denominator is already the same, so that's kind of nice. You can just combine the tops. So I'm going to say 0 less than or equal to x plus 4 over x minus 4, x minus 1 when you factor it, right? Because that multiplies to a positive 4, but adds it to that negative 5. I'm going to set the bottom equal to 0, the top equal to 0. So x equals 4, x equals 1, and x equals negative 4. So I'd say negative 4 to 1 to 4. Again, my favorite test point is 0. So I just plug it in, look at the sides, to be positive over negative times a negative, which would be a positive over a positive, which would be a positive answer. So is a positive answer going to be less than or equal to 0? The answer is no. So on this one, again, the bottom's going to be your open circles. The top's going to be a closed circle because it's greater than or equal to. All right, this one was false. So then I want to shade to the left, shade the next section, and then skip the last one. So I would say my answer would be negative infinity to negative 4, union 1, 2, 4. These last two are just independent practice problems. I'm not going to work them out. I'm just going to leave them on here for you guys to practice, and I'll put the answer at the bottom. So go ahead and pause the video. You guys can try these and just see if you get them right. So just for the sake of the video, I'm not going to solve that one, just because it's kind of long already. So make sure you complete 4.5b as your homework. We will take a quiz next class, and that'll be it for the week, for the quarter. Make sure you get both these things done so they can put them in the grade book and they go on the quarter grade. If you have any questions, please reach out, let me know. Otherwise, have a great day.